You open Claude Code on a Monday morning. You type, "Do you remember the auth system we were building last week?" It doesn't. New session. Clean slate. The AI has no idea who you are, what you decided, or why you made those decisions. So you spend the next 20 minutes re-explaining everything you already figured out. And then halfway through, Claude writes var OAuth config. You catch it, you correct it, you move on. Then you ask for a security review. Claude looks at the code and says, "Looks fine." It's not fine. There's a vulnerability sitting right there. Claude just didn't catch it. You ship. The bug ships with it. This is vibe coding. And if this sounds familiar, you are not alone. Most AI builders are working exactly like this right now. Today, I want to show you why this breaks down and the 195,000 star GitHub project that completely fixes it. Here's what's actually happening when you vibe code. Picture this. You have a conversation with Claude on Friday. It goes well. You make a key decision. Store OAuth tokens in an HTTP-only cookie, not local storage. Good call. Secure. Monday comes, new session. Claude doesn't know about that decision. You forget to mention it. Claude stores the token in local storage. That's a cross-site scripting vulnerability. It ships. That's not an AI failure, that's a memory failure. And it happens every single week. Now picture your code review process. You ask Claude, "Is this secure?" Claude looks at the code in the same session where it just wrote the code. It has no fresh perspective. It's basically reviewing its own homework. Of course it says it looks fine. And then there's the slow rot. Every session you have to remind Claude, write tests first. Don't use var. Run lint before committing. One day you're rushing, you forget. The debt stacks up. Here's the real problem. In traditional software engineering, we solved all of this years ago. CI/CD pipelines run your tests automatically. Code review enforces your standards. Linters catch your formatting. None of that depends on you remembering to ask. But with AI, we threw all of that away. We went back to relying on our own memory and self-discipline every single session. The fix isn't to prompt better. The fix is to build the same systems around your AI that you already built around your code. That's the insight behind everything I'm about to show you. Let me give you a mental model that makes this click. Think about a horse harness. A horse is powerful, unpredictable. Without a harness, that power goes everywhere. With a harness, the same power pulls a carriage, controlled, directional, useful. Your AI is the horse. Harness engineering is how you build the harness. Here's the idea in one sentence. You stop trusting yourself to remember the rules, and you force the system to remember them for you. That's it. That's the whole thing. Instead of telling Claude, don't use var every session, you write a rule that puts that constraint in front of Claude's eyes permanently, every session, automatically. Instead of asking, is this secure, and hoping Claude catches everything, you build a dedicated security reviewer that runs independently with fresh eyes before anything ships. Instead of re-explaining last week's decisions every Monday morning, you build a system that saves those decisions when the session ends and loads them back when it starts. None of this requires a new AI model. None of this requires better prompting. It just requires treating your AI setup like the engineering system it actually is. Quick note on terminology so nothing confuses you later. Prompt engineering is about what you say in a single conversation. Harness engineering is about what happens automatically across every conversation, every session, every file. Those are very different things. We're doing the second one today. Before I show you ECC, you need to understand what Claude Code actually lets you build with. Think of it like a kitchen. The ingredients already exist. The question is whether you know how to use them. Claude Code gives you 5 layers of control. Layer 1 is knowledge. 2 tools here. Rules are laws. They load every single session. No trigger, no asking, no matching. They are just always there. Never use var. 3 words. Now Claude never uses var. Forever. Done. Skills are expertise. They sit in a library and Claude pulls them out when the task matches. You are building a Django view set. The Django skill activates. You are writing a TDD test. The TDD skill loads in. Only what you need when you need it. This keeps Claude's working memory clean. Think of it this way. Rules are the signs on the wall that everyone sees every day. Skills are the reference manuals on the shelf that you grab when you need them. Layer 2 is automation. Hooks are triggers. Every time Claude is about to do something, write a file, run a command, finish a session, a hook can fire. It can check things, fix things, save things, or block things entirely. And it does this without you asking. Every time, automatically. Imagine a safety inspector standing at the door of every tool Claude uses. That's a hook. Layer 3 is delegation. Sub-agents are specialists. When Claude hits a task that needs deep focus, a full security audit, a complex architecture review, it hands the task to a sub-agent. The sub-agent works in its own private workspace, comes back with a result, and the main conversation stays clean and focused. Think of it like hiring a consultant for one specific job. They do the work. They report back. They don't have access to everything else. Layer 4 is external connections. MCP, Model Context Protocol, lets Claude use outside tools the same way it uses built-in ones. GitHub, databases, search engines, all called directly, like they were always part of Claude. One rule: keep your active tools under 80 or you'll clog the pipeline. LSP, Language Server Protocol, gives Claude compiler-level understanding of your code. Not just reading text, actually understanding which functions call which, where types flow, where errors live. Layer 5 is packaging. A plugin bundles everything, your rules, skills, hooks, sub-agents into one folder. One install command. Your whole team gets the same setup instantly. 5 layers. Now let's see what someone built with all of them. ECC stands for Everything Claude Code. It is a free, open-source plugin that someone built after winning an Anthropic hackathon. And when I say everything, they meant it. 61 specialized sub-agents, 246 skills, 45 automated hooks, rules for 12 different programming languages, all pre-built, all ready to install. But I don't want you to think about ECC as a big config dump. That's not what makes it interesting. What makes it interesting is 3 specific design decisions. Decision 1, it installs selectively. You tell it what you work with. TypeScript, Django, Go. It figures out exactly which pieces you need and puts them exactly where they belong. Nothing extra. No bloat, just what fits your stack. Decision 2, it has 3 levels of strictness. You set one environment variable: minimal, standard, or strict. In minimal mode, it just handles memory. Saving and restoring what matters between sessions. That alone is worth it. In strict mode, it adds aggressive safety gates, full governance tracking, the works. High protection, high oversight. You pick the level that fits your moment. Prototyping fast? Use minimal. Shipping financial code? Use strict. One variable, no config file surgery. Decision 3, it learns from your work. Every time Claude uses a tool, ECC quietly observes. It watches patterns. When it sees something repeat enough times with enough confidence, it writes a new skill. Automatically. Your one-off solutions turn into permanent knowledge without you doing anything. That third one is genuinely new. I haven't seen it anywhere else. Let me show you exactly what changes when you install ECC. Same task both times. Add Google OAuth to a TypeScript application without ECC. Monday morning. New session. You ask Claude, do you remember the login system we were building? It doesn't. You dig through Git history, you re-explain the PKCE authentication flow. 10-15 minutes gone before you write a line. You say add Google OAuth support. Claude starts writing. It uses var. You catch it. Use const fixed, but you had to catch it. Claude skips straight to implementation. You remind it. Tests first, then code. It reorders, but again, you had to remember to say that. Feature is done. You ask, is this secure? Claude looks at what it just wrote and says, looks good. Token in local storage. That's fine. It's not fine. Local storage is exposed to cross-site scripting attacks. Any malicious script on the page can read it. You should be using an HTTP-only cookie, one that JavaScript cannot touch at all. Claude missed it because it reviewed its own work. You close the terminal. Nothing is saved. No decisions. No context. No memory. Tuesday morning. Same thing. Start from 0. Now with ECC, you open the terminal. Before you type anything, session start hook fires automatically. It loads everything from last session. Claude already knows the PKCE flow. It already knows you use HTTP-only cookies. It already knows var is banned. You say, add Google OAuth support. Claude uses const automatically. No reminder. Claude writes the test first. Red bar, then the implementation, green bar. No reminder. The TDD skill matched the task and kicked in. The pre-tool use hook checks the command before it runs. Post tool use hook formats the file after. Quiet, automatic, invisible. You say, review the security. Claude doesn't review it itself. It delegates to the security reviewer subagent, a separate AI with read-only access, and nothing else in its context except this code and the job of finding vulnerabilities. The subagent comes back. It found something. The Google OAuth redirect address needs a whitelist. Right now, the code accepts any address. That's a vulnerability that lets attackers redirect users to malicious sites after login. Caught. Automatically. Without you asking the right question. You say, fix it. Claude fixes it. You close the terminal. Stop hook fires. It extracts today's decisions. Google OAuth uses authorization code flow, redirect addresses must be whitelisted, and saves them to the database. Tomorrow morning, Claude knows all of this before you say a word. Now think about that redirect vulnerability for a second. In the vibe coding version, it shipped. It sat in production. Maybe for weeks. Maybe until someone found it the hard way. In the harness version, a specialist caught it before the session even ended. Same developer, same AI, completely different outcome. I want to zoom in on two specific mechanisms inside ECC, because these are ideas you can take and use in your own setup today, even without installing ECC. The first is cross-session memory. Claude Code has a built-in memory system, but it's a black box. You can't control what it saves, how it saves it, or what format it uses. ECC builds its own, and it is completely transparent. Here's how it works. When your session ends, a stop hook fires. It extracts the decisions made in that session, what you built, what you chose, what you learned, and saves them to a local database. When your next session starts, a session start hook fires. It reads that database and injects the context directly into Claude's working memory. By the time you type your first message, Claude already knows where you left off. The database itself is SQLite, a single file that lives on your machine. No cloud. No vendor, no subscription. Your decisions stay yours. You could build a simplified version of this yourself in an afternoon. 2 hook scripts, 1 database file. That alone would eliminate the Monday morning re-explanation problem completely. The second is layered security gates. Think of it as 2 checkpoints. One before, one after. Before Claude touches anything, the pre-tool use hook checks. Should this actually happen? Is someone trying to push code without running the tests? Is the AI about to weaken a lint rule instead of fixing the underlying bug? Is it trying to start a development server in the wrong environment? If yes, block it. Hard stop. After Claude finishes, the post-tool use hook checks. Was the output actually good? Auto-format the file. Scan for leftover console logs. Run the full quality check, lint, type check, test. And then there's GateGuard, the most aggressive piece. The first time Claude tries to edit any file, it gets stopped. Completely. Before it writes a single character, it has to answer 3 questions. Who else imports this file? What does the data look like going in and out? Does Claude actually understand what you want? Only when Claude can answer all 3 does the gate open. Yes, this slows things down. That's the point. For a payment system, a medical record, an authentication module, slow and correct is worth it. For a prototype you're throwing away tomorrow, turn it off. 1 environment variable, minimal, and GateGuard goes quiet. You don't need to install ECC to start thinking like this. Here are 4 principles you can apply to any project today. 1, walls and shelves. Some rules belong on the wall, visible always, non-negotiable, never needing to be asked. No VAR, minimum test coverage, no pushing without review. These go in rules files, they load every session. Claude always sees them. Other knowledge belongs on the shelf. Detailed, contextual, only useful sometimes. Your TDD workflow, your database migration checklist, your deployment steps. These go in skills, pulled out when needed. Out of the way when not, wall for laws, shelf for expertise. 2, invisible inspectors. The best quality checks are ones you never have to think about. You don't ask for formatting, it just happens. You don't request a security scan, it runs. You don't remind Claude to save context, it saves. Hooks make this possible, but keep them fast. A hook that slows Claude down will frustrate you until you remove it. Under 200 milliseconds for anything that blocks. Anything complex, run it after or run it in the background. 3, fresh eyes through subagents. When a task genuinely needs a different perspective, a security audit, an architecture review, a code quality check, Don't ask the same Claude that wrote the code to review it. Spin up a subagent. Give it only the tools it needs. Read access, but not write access for a reviewer. Fresh context, not the one that just spent 2 hours building the thing it's supposed to critique. A reviewer who can also edit is not a reviewer. It's just more Claude. 4. Local first, then share. Do not start with a plugin. Start with a single hook script in your own project. Get it working, trust it. Then add a second, then a skill, then package it all when you are confident it actually helps. ECC itself started this way. One mechanism at a time, tested in real work, assembled into a package only after each piece earned its place. Build the harness, then give it to your team. Here's what I want you to take away from this. Vibe coding is not a skill problem. It's a systems problem. You are a skilled developer. The AI is capable. The gap is the infrastructure around them. Build the infrastructure. Rules that enforce your standards without you asking. Hooks that run your quality checks without you remembering. Sub-agents that review your work with genuinely fresh eyes. Memory that carries context across every session you ever open. That's the difference between a developer who corrects their AI 10 times a day and a developer who ships with confidence. The ECC repo link is in the description. Even if you never install it, read the architecture. The patterns are worth more than the code. If this is the kind of content you are looking for, no hype, no tutorials, just real breakdowns of how to build AI systems that survive production, subscribe to DeepWing.